33 engines. SpaceX caught one, 15 seconds, then brought the ship home. And they called it a complete success. This was not a standard static fire. SpaceX wasn't testing Ship 40's raw power that day. They were setting up for something Starship has never done before, on actual orbit. And if this step failed, Flight 14 couldn't happen. In this video, I'll break down why a single engine was enough, why 15 seconds is not a random number, and why Ship 40 coming home early is actually a good signal, not a bad one. Let's get into it. SpaceX just confirmed something the entire Starship program has never pulled off. Not catching the booster, not a soft landing. This, a successful Raptor, 3 restart, under simulated deorbit burn conditions. Sounds small, but this is the data point Flight 14 cannot fly without. Per SpaceX's official statement, this test was defined as a full-duration simulation of a deorbit burn. Not a standard static fire, not a performance test. This was a qualification test for one specific scenario. A single engine, restarting after hours in cryogenic vacuum conditions, burning for exactly 15 seconds, stable, then shut down, and it worked. That 15 seconds is not arbitrary. It's the actual burn duration required for a deorbit maneuver on a real Starship orbital trajectory. Engine thermal preconditioning before ignition. Partial propellant load, not full. Every parameter designed to replicate on-orbit conditions as closely as ground testing allows. Why does this matter so much for Flight 14? Because this is the first time in Starship program history the vehicle is required to break itself on real orbit. No precedent, no real flight data confirming Raptor 3 can execute this. That test at Massey was the only data point they had, before betting everything on Flight 14. What actually happened? The details most coverage missed. Most reports only covered the successful firing, but there's one critical detail that got buried. The first attempt. The igniter fired. Then the sequence stopped, just before engine ignition. This was not a random anomaly. This was a controlled abort. The system detected a parameter outside acceptable limits and shut itself down. What matters here isn't that the abort happened. It's what type of parameter triggered it. SpaceX hasn't disclosed specifics, but based on abort patterns across the Starship program, the most likely candidates are one of 3. Fuel line pressure not yet within threshold, engine preconditioning temperature not yet stable, or a sensor reading outside its acceptable range. All 3 are resolvable within 24 hours, and the timeline confirmed exactly that. Next day, successful test. Here's the point I want to drive home. A controlled abort is a good sign, not a bad one. The system performed exactly as designed. It caught the problem before the problem became an incident. Compare that to older generation rocket programs, where abort detection wasn't always fast enough or sensitive enough. With Starship, this system is proving it works. Why did Ship 40 go home early? The part no one is saying. Let me be direct about this. After the single-engine test succeeded, SpaceX rolled Ship 40 back to Mega Bay 2. No 6-engine test, no multi-engine sequence. Straight back. Official reason: swap 1 or more engines. What does that actually mean? There's a specific issue with at least 1 engine in the 6-engine cluster. Serious enough to delay the 6-engine test, but not serious enough to scrap the plan entirely. I won't call this entirely good news. Every engine swap adds time. Every swap adds another opportunity for new issues to surface during removal and reinstallation. And with Flight 14's timeline under close watch, this is the real variable to monitor. But here's the important context. Data from the Falcon 9 program shows SpaceX has an engine swap process refined over many years. With the current Starbase technical team, swapping 1 or 2 engines is not a multi-week job. Conditional projection. If the swap completes within 7 to 10 days with no new findings, the 6-engine test could happen within the next 2 weeks. If additional systemic issues surface during disassembly, the timeline extends, and that directly impacts Flight 14's launch window. I'll track this closely and update the moment new information is available. Deep analysis. What is SpaceX doing differently from everyone else? This is the part I think most channels haven't covered. Look at Ship 40's full test sequence. Single engine qualification test. Separate. 6-engine performance test. Separate. 2 objectives. 2 tests. 2 independent data sets. This is a shift in test engineering philosophy inside the Starship program. In Starship's early phases, SpaceX routinely bundled multiple objectives into a single test. The result? When something went wrong, isolating the root cause was hard. Data got contaminated by too many variables firing simultaneously. Now, the pattern is changing. Qualification first, performance second. Each test is designed to answer one specific question. Compare that to NASA's approach with Orion. NASA uses dedicated vacuum chambers, altitude simulation facilities, to test engine restart in conditions as close to flight as possible. Significantly higher cost, much longer setup time, but higher data quality. SpaceX chose the opposite trade-off. Use the actual launch pad. Precondition the engine instead of simulating the environment. Data quality isn't perfect, but time to data is dramatically faster. Fair question worth asking. Is data from ground-based preconditioning sufficient to predict behavior in actual orbital conditions? Honest answer, we don't know for certain yet. This is the first time this test has been conducted this way. With Raptor 3, in this specific context, Flight 14 will be the real exam. But here's what I believe based on the available data. SpaceX has accumulated enough test data from McGregor, enough to understand Raptor 3's thermal behavior across a wide range of conditions. Ground preconditioning isn't perfect, but it's not a shot in the dark either. It's the best ground-based approximation possible, given the current timeline. If this analysis is giving you a sharper lens on what's actually happening at Starbase, subscribe and hit the bell. I'll break down the 6-engine test results the moment they drop. The bigger picture. What is Starbase actually building? While Ship 40 was being tested, Starbase was not standing still. And when you look at everything happening in parallel, a very clear pattern is forming. Gigabay. Based on current site imagery from Starbase, exterior cladding is being completed on the upper sections. The tower crane has climbed additional sections to keep pace. When Gigabay becomes operational, SpaceX's production capacity more than doubles compared to both megabays combined. This is not linear expansion. This is a step change in manufacturing throughput. Starpipe and the natural gas liquefaction plant. SpaceX has filed permits for an 8-mile natural gas pipeline running directly to Starbase, paired with an in-house liquefaction facility to refine propellant on-site before launch. This is vertical integration at the infrastructure level, not just rockets. When you control your propellant supply chain end-to-end, you eliminate one of the biggest variables affecting launch cadence. Pad 1. Rebuild. Pad 1 is being rebuilt to match Pad 2's exact configuration. Full Raptor 3 specs. Not an upgrade. A full standardization. The engineering logic is straightforward. 2 pads with different specs means 2 different operating procedures, 2 different checklists, 2 different fault trees. Operational error risk compounds with every point of difference. Standardize to a single spec. Eliminate that risk and allow the ops team to scale without pad-specific retraining. These 3 things. Gigabay. Starpipe. Pad 1 rebuild. Are not 3 separate projects. They are 3 pieces of the same strategy, building a fully self-sufficient launch facility, capable of operating at high cadence, with zero dependency on external supply chains. Put that alongside SpaceX stacking tower sections at SLC-37 in Florida, using the Liebherr LR 13,000 crawler crane, with Pad 2 and the chopstick arm being installed simultaneously. The picture sharpens. Starbase in Florida will be 2 independent, fully self-sufficient launch sites, not as backup for each other, but running in parallel. When you look at Ship 40's single-engine test inside that context, the question is no longer, why only one engine? The real question is, What launch cadence is SpaceX building toward? And how fast are they closing the gap? This week's infrastructure data suggests the answer is coming, faster than most people watching this program realize. And that's why Ship 40's upcoming 6-engine test is not just another item on the checklist. It's the most critical checkpoint before Flight 14, in a program running ahead of any timeline anyone has publicly committed to. That's the data. That's the analysis. If this gave you a sharper lens on what's actually happening at Starbase, hit like, share it, and subscribe to the Space Brief. See you in the next one.